Thank you very much, Simon. Who needs PowerPoint when you have a $20 bill in your pocket? I'd now like to welcome Stephen Pear. He is CTO and co-founder of a Bitcoin payments processing company called BitPay, and is going to tell us a little bit about how the currency works and what its advantages can be to businesses, individuals, and perhaps whole economies.
Well, that was, yeah.
Thank you. It's great to be here and participate in this event. I wanted to give my perspective on money after having worked with or studied cryptocurrencies for the last 20 years, and most recently having started a payments company for Bitcoin. And I find that perspective is often helpful when you're analyzing some subject matter to gain a new perspective and see things in a slightly different way and gain insight. And as Alan Kay once said, point of view is worth 80 IQ points. To understand Bitcoin, you really have to understand money first. And money is a protocol. And a protocol is a system of rules that explain the correct conduct and procedures to be followed in formal situations. And that made me think of royalty and how sometimes we don't follow protocol. But some examples of protocols are SMTP. We use SMTP for email to communicate asynchronously. We use HTTP to publish to the world very cost effectively. And then there's something called the Uniform Commercial Code, which is an example of a non-computer protocol. It's a protocol that's implemented in legal language rather than computer language. And the Uniform Commercial Code instructs us on how we should interact with each other in commercial situations. Now, money as a protocol, basically, money sends signals is how we send signals to each other about what we value. And collectively, if you look at how money is used, we can learn the things that people value. And when you take these microeconomic transactions and you aggregate them, you can tell things about what's going on in the economy. And you can make informed decisions about the kind of things perhaps you should be doing, the things you should be investing in, whether you should be saving, or what kind of job you should be seeking. So it's really important that we have a well-functioning protocol. So Bitcoin enabled something that was previously thought to be impossible, and that is the ability to transfer value point to point, person to person, without an intermediary over the internet. And when we talk about a Bitcoin transaction, you're actually transacting, or you're actually transferring an actual asset, and it's settled immediately. Most digital currencies you're actually transferring some kind of a debt or a contract, and it's being facilitated by a third party. In the case of Bitcoin, there is no counterparty risk when you hold Bitcoins. They are only worth what somebody else is willing to pay for them. Now, how does this work? Well, I can download some software, and you can download some software, and then I can send you Bitcoins. But of course, in order to send you Bitcoins, I have to have Bitcoins. And so that creates a demand in the marketplace. I need to go out and either purchase Bitcoins, or I need to do some work to earn Bitcoins. And then once I have them, then I can send them to you. And that is Bitcoin's intrinsic value. And it turns out that that's all forms of money. That's where they derive their value. So most of you probably have one of these in your wallet today. I mean, not a Diners Club, but, but you have a credit card, which is not much more evolved than this Diners Club card. That was invented in the 1950s, and they could not have possibly anticipated today's internet. And yet, a large part of e-commerce on the internet today is conducted with these credit cards. Now, a credit card transaction is very different from a Bitcoin transaction. A credit card transaction is something we call a pull transaction. You go to a website, you put in your credit card number, you give all this personal information to the recipient, and then they use that money, that information, to pull money out of your account. And that is the source of the credit card fraud problem that we have today. And it's a big problem. It's about 1% of GDP, and probably even a lot more than that. About 1 in 50 international credit card transactions is fraudulent. It's a huge problem. Now with Bitcoin, the transaction works a little bit different. I have software called a wallet that I run. And when I want to send somebody Bitcoins, it creates a transaction. It digitally or cryptographically signs that transaction, and then it sends that transaction to the recipient. The recipient receives the exact amount of Bitcoins that I wanted to send them, and they have no ability to access anything more. And so we can process a payment anywhere on Earth with no risk of payment fraud. So let's step back a bit and talk just sort of in broad strokes about the evolution of payment technologies. So here I show commodity money, paper money, digital money, and cryptographic money. In ancient times, we began using metals as money. We started to coin them. And then around the 11th century, paper began to be used as money. Now, why is that? Why did people start to transition to paper? Well, it was more convenient. It was a better payment technology because paper could fit in your wallet. It wasn't as heavy to carry around. It was easier to make change. You didn't have to figure out the exchange rate between gold and silver. So that gave rise to the use of paper as money. It was invented in the 11th century, but it took a few centuries after that before it became widely adopted. Now, digital currencies, it's funny that we're here talking in a session about digital currencies as if that's a new thing. Digital currencies have been with us for probably 50 years. Now, not everybody has been using them for that long, but they've been around for that long. And the world's #1 virtual currency is the US dollar. 97% of all US dollars exist purely as a database entry at the Federal Reserve. And if you still don't believe that we've been using digital currencies for a long time, ask yourself, when was the last time you touched a physical paycheck? So we've been using digital currencies already for a long time. So that brings us to cryptocurrencies. Over the last 20 years, we've seen the development and rise of cryptocurrencies. One of the first ones was back in the 1990s, something called DigiCash. And DigiCash used cryptographic technology to secure their payment system. But it had a flaw, and that flaw was that it was centrally issued. So the currency was only as valuable as the issuer of that currency, DigiCash, and they eventually went bankrupt, and there goes your currency. So Bitcoin's breakthrough was something called a decentralized proof-of-work-based consensus. And what this enabled was for there to be no central issuer. There's no company that issues Bitcoins. They are produced as a function of the protocol. The people that secure the Bitcoin network are actually paid in newly created Bitcoins. So how does that work, and what can that do? Well, it won't answer the riddle of whether the chicken or the egg came first, but if you gave the Bitcoin network a chicken and an egg, the entire network would reach a consensus about whether the chicken or the egg came first. These are millions of computers around the world that would agree on which event came first, and that's really what it's about. It's about ordering of events. And if you have a computer science background, you know that's significant. And this network, by the way, has a lot of utility beyond just payment processing. Ways to create more Bitcoins. I don't think I'll talk too much about this slide. Suffice it to say, you can't actually create Bitcoins. Their issuance is based on a fixed rate of inflation, and they come into the existence by rewarding people that secure the Bitcoin network. And fundamentally, the integrity of the Bitcoin network is rooted in the rules of math and the laws of physics. And interestingly enough, gold is also, and when it's used as a payment system, is also rooted in the same things, and the integrity of the use of gold as a payment system. Here's a couple of data centers. On the left is one of Visa's billion-dollar data centers, and on the right is a mining operation. These are the computers that secure the Bitcoin network. So one is a messy patchwork of systems, and the other is a really, in the case of Bitcoin, it's a really elegant design. The one on the left, both of these are doing fundamentally the same thing. They're trying to secure the payment network and the integrity of the payment network. In the case of the Visa data center, what they're trying to do is apply machine learning algorithms, pattern recognition, and whatnot to detect instances of fraud on the credit card network. And remember, the fundamentally flawed nature of a credit card payment, that pull transaction. On the right, what you've effectively done is commoditized the process of securing, or the business of securing, the payment network. So anybody can go and obtain this hardware. You used to be able to just run it on a normal computer, but now we have specialized computer chips using 28 nanometer process that are custom designed to secure the Bitcoin network. So anybody can go and acquire this hardware, and they can start running it, and they can earn newly created Bitcoins by operating that equipment. And the profitability of that goes up and down depending on the price of Bitcoins and a lot of other factors. How many other people are trying to do that? Now, what this all means is that Bitcoin, in its short time, in the relatively short period of its existence, has bootstrapped the world's most powerful distributed computing network in the history of man. And it is also, I like to describe Bitcoin as the most counterfeit-proof form of payment that we've ever invented. So in Bitcoin, as in life, money isn't everything. I mentioned before that the decentralized network that orders events can be used for a lot of other things, a lot of very cool things. For example, it's not just about sending payments from point A to point B. I can create a transaction that requires 3 out of 5 people to sign that transaction. I can also timestamp documents so that I can have provable evidence that a document existed at a certain point in time, and I don't have to reveal the actual contents of that document ahead of time. It can handle the transfer of ownership of other kinds of assets like deeds and titles. And you can even, people are speculating that one day those Google cars that drive themselves, people are speculating that not only will they drive themselves, but they will also own themselves and be independent economic actors. So when I think about money today, it reminds me of the pre-internet era when we had CompuServe, Prodigy, AOL, and they didn't communicate with one another. And then along came the internet, and they suddenly became linked. Well, here we have a payment system and a money, an open source project that allows us to start to interconnect what I view as a lot of different, separate payment systems, separate monetary systems. And so that makes me really excited about the future, and I can't wait. And that's my perspective on money. Thank you.